Welcome to this highly critical technical session, focusing squarely on applying responsible AI instrumentation across your generative AI and agentic systems using Microsoft Foundry. Let us learn how to secure your enterprise models. Welcome to this session on applying responsible AI instrumentation, focusing on evaluators, safety evaluations, and explanation tooling within Microsoft Foundry. Generative AI enables incredibly powerful creative solutions, but it absolutely requires strict, continuous risk management, because these models can generate dynamic, highly contextual content that is frequently indistinguishable from human creation. If left entirely unchecked, these models can confidently generate harmful, biased, offensive, or factually inaccurate content that can severely damage your enterprise reputation. Therefore, it absolutely requires that data scientists, application developers, and security architects adopt a highly rigorous, responsible approach that actively identifies, continuously measures, and forcefully mitigates these exact risks. Microsoft provides a rigorous four-stage process for responsible generative AI: map, measure, mitigate, and manage. This framework corresponds very closely to the rigorous functions outlined in the NIST AI Risk Management Framework. Today, we focus heavily on the measure and mitigate stages, which heavily rely on deep technical instrumentation. When we talk about instrumentation in generative AI, we are referring to the automated tools, programmatic evaluation scripts, and structural guardrails embedded directly into your deployment pipelines and application architecture. We cannot rely on manual vibe checking. We need mathematical precision. You must rigorously measure the presence of specific harms using automated evaluators, implement robust mitigation strategies such as safety system guardrails, and establish explanation tooling through transparent user experience design. By instrumenting your AI agents properly, you transform subjective safety goals into objective, verifiable engineering quality gates. Let us dive into how we map these risks and configure our automated measurement tools to build a rock-solid, trustworthy enterprise AI solution. This JSON representation outlines the four foundational stages of Microsoft's responsible AI framework. True technical instrumentation integrates automated tooling deeply into the measure and mitigate phases of this iterative lifecycle. This flowchart visualizes the continuous, iterative, responsible AI lifecycle. You map the risks, objectively measure them using instrumentation, implement strict mitigations, and actively manage the system, feeding telemetry back into the mapping phase. Before we can instrument our code with automated evaluators and rigorous safety metrics, we must first establish exactly what we are measuring. This brings us to the very first stage of the responsible generative AI process, the map phase. You cannot simply apply generic security templates to an agentic system. You must deeply understand your specific, unique risk profile. The mapping stage consists of four highly analytical, sequential steps. First, you must explicitly identify the potential harms. For example, a medical advisory agent carries vastly different risks regarding physical harm than an internal IT help desk bot. Second, you must aggressively prioritize these identified harms based entirely on their potential severity and their statistical likelihood of occurrence in the real world. Third, you must actively test and empirically verify these prioritized harms against your initial model prototypes to see if the base model is naturally vulnerable to them. Finally, you must comprehensively document and share these verified harms across your organization. A critical best practice here is creating a formal AI impact assessment. This vital document meticulously records the exact business purpose, the expected user interactions, and the specific prioritized harms for your solution, ensuring complete architectural transparency. Let us consider a practical example. If you are building an AI agent intended to process financial loan applications, your AI impact assessment must explicitly prioritize the risk of demographic bias and unfair decision-making. You would then document how the user interacts with the system, noting that the model must never use protected characteristics. By thoroughly mapping your unique threat landscape and establishing this formal documentation, you secure alignment between your compliance teams and your software engineers. Your AI impact assessment acts as the foundational blueprint for your entire instrumentation strategy, dictating the exact automated evaluators you must configure in the subsequent measure phase. This conceptual YAML file represents the codified output of the map phase. Documenting these specific, prioritized harms in an AI impact assessment provides the exact blueprint for which programmatic evaluators the engineering team must implement. This diagram details the map workflow. Once you have successfully mapped your risks in the AI impact assessment, you transition directly into the measure stage. In this phase, manual testing and log inspection are completely insufficient for enterprise scale. Instead, you must systematically quantify the frequency of harmful or low-quality outputs using automated evaluators within the Microsoft Foundry SDK. Automated evaluators allow you to programmatically, objectively, and continuously measure the exact performance of your deployed AI agents using highly standardized mathematical criteria. When you execute an automated evaluation, the Foundry SDK processes a comprehensive dataset of predefined test queries against your live agent and calculates precise scores. For general performance and reasoning quality, you will utilize three primary metrics. The fluency metric accurately measures linguistic correctness and natural language quality, ensuring your agent maintains a professional, human-like communication style. The relevance metric precisely determines if the generated response accurately addresses the original user prompt, rather than just returning vaguely related keyword matches. Finally, the groundedness metric is absolutely critical for agentic systems utilizing retrieval augmented generation, or RAG. Groundedness mathematically verifies that the information in the final response comes strictly from your provided enterprise knowledge base, completely preventing the generative model from hallucinating dangerous fabricated facts from its base training data. This programmatic approach to measurement beautifully transforms subjective quality assessments into objective, highly actionable engineering data. You no longer have to guess if a new foundation model performs better than the old one. Your automated evaluators will prove it definitively. Implementing these evaluators directly in your Python code using the Azure AI Project's client library ensures that every single iteration of your agentic workflow is rigorously tested against your most challenging scenarios before reaching production. Here we instrument the pipeline to programmatically evaluate general performance metrics. By enforcing a strict assertion on the groundedness metric, the code automatically blocks deployments if the agent hallucinates data. This visual outlines the automated evaluation quality gate. The SDK programmatically scores fluency, relevance, and groundedness. While measuring general performance metrics like fluency and relevance is important, measuring your agent's vulnerability to generating toxic or malicious content is absolutely critical. This requires specialized safety evaluations and targeted risk detection instrumentation. Within the measure phase, you must systematically establish a concrete performance baseline that quantifies the exact frequency and severity of harmful outputs. You achieve this by establishing comprehensive testing datasets filled with intentionally provocative, malicious, or highly ambiguous prompts. You then programmatically run these targeted test datasets against your deployed model using the Microsoft Foundry SDK's evaluation tools. Instead of measuring grammar, these specific safety evaluations measure critical security metrics, such as the hate speech defect rate and the self-harm defect rate. By submitting a massive batch of adversarial prompts, often referred to as red teaming data, and analyzing the resulting defect rates, you mathematically quantify your model's baseline vulnerability to sophisticated jailbreak attacks and policy violations. This gives you a clear, objective percentage of how often your system fails under pressure. If your safety evaluation returns a high defect rate, it clearly indicates that your foundational model is too permissive and requires immediate intervention. The resulting metrics are not just numbers. They are the definitive health indicators of your AI system's compliance with corporate safety standards. If your hate speech defect rate spikes after you switch to a smaller, more cost-effective language model, your automated safety evaluation immediately flags this unacceptable regression. You can then make an informed decision to revert the change or apply stronger prompt engineering constraints. By instrumenting your codebase to execute these targeted safety evaluations nightly, you proactively detect emerging vulnerabilities. This relentless, automated measurement is the true hallmark of responsible AI. This Python snippet demonstrates targeted risk detection. By actively running a dataset of intentionally provocative prompts through the automated evaluator, you mathematically calculate the model's defect rate for severe policy violations. This flowchart maps the safety evaluation process. Adversarial datasets are fed into the safety evaluator to calculate specific defect rates. Armed with precise data from your automated evaluators and safety evaluations, you now move to the mitigate stage. Mitigation requires a defense in-depth, layered architectural approach. Relying on a single security filter is incredibly dangerous. In Microsoft Foundry, mitigations are applied across 4 distinct layers: the model layer, the safety system layer, the system message layer, and the user experience layer. At the model layer, you carefully select the appropriate foundational model, or use fine-tuning. However, the most critical technical instrumentation occurs at the safety system layer. Here, you configure content safety guardrails, which act as a highly intelligent, real-time natural language firewall. When a user submits a prompt, this safety system instantly analyzes the text. If it detects malicious intent, such as a jailbreak attempt, it aggressively intercepts and completely blocks the request before it ever consumes expensive compute resources. Crucially, these guardrails operate bidirectionally. They also scan the model's generated output, ensuring that if a safe prompt somehow triggers a toxic response, the outbound filter blocks it. Moving down the stack, the system message layer acts as a strict behavioral guardrail. By explicitly defining the AI's role, professional tone, and absolute boundaries within the system prompt, you tightly constrain its cognitive freedom. Implementing a rigid when unsure policy commanding the model to state "I do not have that information" instead of guessing forcefully prevents hallucinations. This layered strategy guarantees that even if a highly sophisticated prompt bypasses your system instructions, the outbound safety filter catches the violation. Furthermore, you must continuously log every intercepted event. Monitoring these blocked requests allows your security team to analyze emerging attack vectors and iteratively refine your guardrails. This active mitigation represents the ultimate technical enforcement of your responsible AI policies. This critical error handling logic demonstrates infrastructural mitigation. When a user attempts a jailbreak, the safety system layer intercepts the prompt and throws a content filter error, which your code logs for threat analysis. This visual demonstrates layered defense in depth. Prompts face inbound safety guardrails, strict system message boundaries at the LLM level, and a final outbound safety guardrail before the output is ever delivered. Our final mitigation layer is the user experience layer, which heavily incorporates explanation tooling and operational transparency. When users interact with generative AI, they must clearly understand they are communicating with an artificial system, and they must have tools to verify the AI's logic. Explanation tooling is primarily implemented by surfacing citations and grounding data directly in the application interface. If your agent utilizes retrieval augmented generation, it is absolutely mandatory that every factual claim includes an explicit, verifiable source reference. By displaying exactly which enterprise document the model used to generate its answer, you provide immediate, transparent explanation tooling that builds immense user trust. Additionally, you must design your user interface to include robust user feedback mechanisms, such as simple upvote and downvote buttons or reporting forms. This allows end users to flag inappropriate or unhelpful responses, generating invaluable telemetry that feeds directly back into your continuous monitoring dashboards. This perfectly transitions into the final stage of the responsible AI lifecycle: manage. To responsibly manage your solution, you must implement a phased delivery plan, starting with a controlled pilot release before a global rollout. This allows you to collect real-world feedback and identify unexpected edge cases safely. As you monitor live telemetry from your explanation tools, feedback buttons, and automated safety gates, you iteratively refine your system instructions. Responsible AI requires continuous operational vigilance. If you found this deep dive on responsible AI instrumentation valuable, please like and subscribe to the channel. To master these critical concepts, visit quicktechie.com for premium certification prep, featuring extensive Q&A banks, comprehensive ebooks, expert audiobooks, and exclusive interview guides. Keep building safely. This JSON payload represents the user experience mitigation layer. By explicitly returning citations and transparency notices to the front end, you provide crucial explanation tooling that helps users verify the model's factual accuracy. The continuous management lifecycle, a phased pilot release, utilizes explanation tooling and feedback mechanisms to collect telemetry. Teams analyze this data to identify edge cases, refine instructions, and eventually authorize a global rollout.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.